Hi, this is Mr. Mack. This is going to be a concept video on adding and subtracting rational expressions. Now, to start off with, I want to talk to you about just adding fractions for a moment. Let's say we have two 14ths and three tenths, and we want to add these two fractions together. To add two fractions together, you have to have the same denominator for each fraction. Now, ordinarily what we do is we search for the lowest common denominator, and the lowest common denominator turns out to be the lowest common multiple of the two fractions. Now, you were taught in elementary school, perhaps middle school, to find the lowest common denominator by writing down each of the denominators and then writing multiples of it until you came to the same number in both lists. And that's not the method that we're going to be taking a look at here. The method we're going to be using is this, and let's see if I can state this. The lowest common denominator is the product of the smallest set of prime factors that contains the prime factorization of all your denominators. I'm going to use the denominators. Now, in the case of the two fractions I have here, 14 is 2 times 7, and 10 is 2 times 5. Now, the smallest set of prime factors that contains the prime factorization of both 14 and 10 is 2 times 5 times 7. Notice, here's 2 times 5, which is 10, and here is 2 times 7, which is 14. So 2 times 5 times 7 is 70, and that is the lowest common denominator of 2 14ths and 3 tenths. So if we look at it, 2 14ths, 14 is 2 times 7. What prime factor in this set of prime factors am I missing? Well, I'm missing the 5. So if you multiply the numerator and denominator by 5, you'll get the lowest common denominator for the denominator. Now, we have also 3 tenths. 10 is 2 times 5. Notice I'm missing the 7. So we can multiply numerator and denominator of this fraction by 7. And what we get is 10 over 70 plus 21 over 70, which becomes 31 over 70. Now let me also mention that even though we used the lowest common denominator when we added the fractions, there is no guarantee that our answer will be the fraction in lowest terms. You always still need to look at that fraction and ask yourself, does it reduce further? Now let's take a look at a couple of examples. If you have 6xy, 18x squared, and 45y cubed as your three denominators, the question would be, what is the lowest common multiple of those? Or What is the greatest common denominator? Well, we're going to write the factorizations of each one of these. 6xy becomes 2 times 3 times x times y. 18x squared becomes 2 times 3 squared times x squared. And 45y cubed becomes 3 squared times 5 times y cubed. Now the lowest common multiple needs a factor of 2 because there's a 2 in this first one here. Now there's also a 2 in the second one, but 1, 2 is going to be enough because no single number has more than one factor of 2 in it. Now if we look at the 3's, the first term, 6xy, has a factor of 3. 18x squared has 2 factors of 3, and 45y cubed has 2 factors of 3. Now, one factor of 3 isn't enough here because we need 2 factors of 3 for the 18x squared and for the 45y cubed. But we don't need any more than 2 factors of 3 for any one of these numbers, so 2 factors of 3 will be enough. Now we have a factor of x in the first one, 2 factors of x in the second one, so we need 2 factors of x. We have a factor of y in the first one, none in the second, but 3 in the third, so we need 3 factors of y in our lowest common multiple or lowest common denominator. Now this gives us we also need a 5. I neglected to mention the 5. We need a 5 because the third one has a factor of 5. So what we get is 2 times 3 squared times 5, which is 90, x squared y cubed for our lowest common denominator. Now it's pretty easy also to figure out what you need if these were denominators. Let's say we had 1 over 6xy plus 1 over 18x squared plus 1 over 45y cubed. It's pretty easy to figure out what you need to multiply each numerator and denominator by, because 90x squared y cubed is our lowest common denominator. But if you just, let's see if I can get a highlighter here. Okay, if you just take your lowest common multiple and say, all right, we've got a 2, we've got one of the 3's, and we've got one of the x's, and we've got one of the y's in 6xy. Well, that leaves us with needing another 3, another x, 2 y's, and a 5. So we would know that the first fraction needs to be multiplied by 15xy squared over 15xy squared. Now, the second one, let's see, can I get rid of these? Yeah, there we go. The second one, we'll use this color. We have 18x squared, so that's both of the 3's and both of the x's and the 2. Now, that means we're still going to need 5y cubed. So the second fraction would be multiplied by 5y cubed over 5y cubed. And then for the last one, we have 45y cubed. Now 45y cubed, let's use, let's see that one. 45y cubed had the 5 and the 3 squared and the y cubed, and what is left is 2x squared. So we would multiply this fraction by 2x squared over 2x squared. And then what happens is the denominator is going to be 90x squared y cubed in all 3 cases. And what we're doing is we're adding 15x squared y times 1 plus 5y cubed times 1 maybe it wasn't a good idea for me to use all ones in the numerator, plus 2x squared times 1. So the answer would be 15xy squared plus 5y cubed plus 2x squared all over 90x squared y cubed. All right, now let's take a look at a couple of examples. Example number 1, 3 over 10ab plus 5b squared over 14a squared. Now, in this particular case, both of our denominators are monomials, so you can see that the factors of 10ab are 2 times 5 times a times b, and you can see that the factors of 14a squared are 2 times 7 times a times a. So our lowest common denominator is going to have a factor of 2, it's going to have a factor of 5, it's going to have 2 factors of a, and it's going to have a factor of b. So here's 2, 5ab, so we need to multiply the first fraction by a over a. Now, here's, whoa, I missed the 7. Let's go back and do this again. 2, 5, a, b, and 7. Okay, so the first fraction actually is going to need to be multiplied by 7a over 7a. There we go, that's better. Now, the second one, we have 2 times 7 times a, so we're left with 5b. So the second fraction needs to be multiplied by 5b over 5b. Now what that gives us is 21a plus 25b cubed over 2 times 5 times 7, that's 70a squared b. And we're done with that one. I need to be careful about not missing those 7s or missing numeric factors. All right, let's try one that doesn't have just monomials in the denominator. How about 3x plus 4 over x squared minus 9 minus 11 over 8x plus 24. Now this first denominator, excuse me, I think I said x squared minus 9, but I didn't write the squared. This first denominator factors into x plus 3 times x minus 3. And the second denominator factors into 8 times x plus 3. So now we need a factor of, in our lowest common denominator, we need a factor of 8 from here. We need a factor of x plus 3. Actually, that's in both of them. And then we need a factor of x minus 3 from here. So if you look at this, the first fraction needs to be multiplied by 8 over 8. And the second fraction needs to be multiplied by x minus 3 over x minus 3. Now what we get then is the first fraction becomes 24x plus 32 over 8x squared minus 72, and then minus the second one becomes 11x minus 33 over 8x squared minus 72. Now in this particular case, I would like to warn you about this negative sign right here. This negative sign is just waiting to have you make a mistake, because what you're doing is you're subtracting this fraction right here from the first fraction. What that means is you're subtracting an 11x and you're subtracting a negative 33. What I recommend that you do when you get to this particular point, when you're ready to go ahead and do the subtraction, is change this to a plus sign and make one negative sign mark, either a negative or change a negative to a positive, on each term in the fraction that follows that. If you do that, then you will have less chance of making a mistake when you actually add these like terms together. You see, what we get is 24x plus 11x, negative 11x, which is 13x. And then 32 plus 33, which is going to be 65. And that's all over 8x squared minus 72. Now, the numerator does actually factor into 13 times x plus 5, but the factors of the denominator are 8, x plus 3, and x minus 3, so the fraction doesn't simplify any farther. So that would be the answer to that question. Now let's try one that may be even a little bit more complicated. How about 8 over x squared minus 6x minus 16, that's an x there, plus 9 over x squared minus 3x minus 40. Okay, now, first of all, we want to add these fractions, so we need to factor the denominators. This denominator factors into x minus 8 and x plus 2. And we'll just replace that with that. This one factors into x minus 8 times x plus 5. I'll take care of that one. Now our lowest common multiple needs to have a factor of x plus 2. It needs to have a factor of x minus 8. And it needs to have a factor of x plus 5. See, here's the first denominator right here. And here's the second denominator right there. So this is the smallest list of prime factors that contains the prime factorization of both denominators. So it's pretty easy to see that if this is the denominator of the first fraction, then it needs to be multiplied by x plus 5 to be the lowest common denominator. So we'll multiply by x plus 5 over x plus 5. And here's the second denominator right here. And so we can see it needs to be multiplied by x plus 2. So we'll multiply by x plus 2 over x plus 2. Now, we get then a fraction whose denominator is the lowest common denominator, x plus 2, x minus 8, x plus 5. Now the numerator becomes 8x plus 40 plus 9x plus 18. Now when we add these together, we're going to get 17x, that's 8x plus 9x, plus 58, and that's all over x plus 2, x minus 8, x plus 5. Now there are no factors of the numerator, so there aren't any that would cancel with the denominator. So we're finished here. Now one thing I would like to mention, when the directions say simplify, they mean for us to do the addition. Now also this numerator is in simplified form, it's not in factored form, but the denominator is in factored form. Truthfully, to finish this problem up, you would have to take these three polynomials and multiply them together. But ordinarily, when there's more than two, even though the directions say simplify, we stop at this particular point and we just leave the denominator in factored form. So that's okay with me if you want to do that. All right, now, we want to take a look again at complex fractions. So what we've done so far is we've looked at complex fractions that had the same denominator. That was in the last, the same denominator in the numerator and in the denominator. So what we're going to do this time is we're going to try a complex fraction where the fractions in the numerator and the denominator have a different denominator. So how about the 1 minus a over b over b over a minus 1. Okay, and we're interested in simplifying this complex fraction. Now there are two ways to do this, and I'm actually going to show you both ways for this particular problem. One of them may seem more complicated than the other, but what I would say to you is generally it is good to know both methods, because sometimes one method will be easier and sometimes it'll be the other one that'll be easier. So look at this. The first method that we're going to do is we're going to multiply by 1, and the 1 we're going to multiply by is the lowest common multiple of the denominators over the lowest common multiple of the denominators in the numerator and denominator of the fraction. So if you look in the numerator, the denominator we have is b. If you look in the denominator, the denominator we have is a. So the lowest common multiple is going to be a times b. So we'll multiply numerator and denominator of this complex fraction by ab. Now, this is a binomial, so when we multiply ab by the binomial, we have to multiply by each term. And it's obvious that 1 times ab is ab, and then we have a minus sign. Now, you can think of this ab when you're multiplying by a over b as a fraction, ab over 1. And if you notice, the b's here would cross cancel, and you would just have a times a. So we can write this as a squared. Now, in the denominator, again, this is a binomial, so this ab has to be distributed over both terms when we multiply. Now, if you think of the first term here, b over a times ab, we could think of that as ab over 1, and the a's would cross cancel, leaving b squared. And then we have the minus sign, and then ab times 1 is, of course, ab. Now, remember, we have to always check to make sure that the fraction can't be reduced further. Well, in this particular case, the numerator factors because there's a common factor of a. We get a times b minus a. That takes care of the numerator. And in the denominator, there's a common factor of b. So we have b times b minus a also. And what we end up with is, notice the b minus a here will cancel with the b minus a here, and we end up with a over b. Now, the second way to do this problem, let's see here, if I can clone this page. Probably should have done that before I wrote all over it. That's not what I want. What did I do? Huh? Let's try this again. Where are we going here? Oh, there it was. That's the one I want to clone. Okay, now it is cloned. So let's see if I can get all of this. Oh, no, that's not the one I want to clone. Sorry about this. Nope, that's not the one. Nope. This is embarrassing. Oh, there it is. So I did clone it? I did. Okay, well, just didn't realize. Okay, here we go. All right, so we want to get rid of the green stuff. Now, what we're going to do this time, get rid of that green. Can I get that green out of there? Yeah, there we go. What we're going to do this time is we're going to first take the numerator, which is 1 minus a over b, and we're going to go ahead and make that, we're going to go ahead and do that subtraction. So in other words, if we're going to subtract a over b from 1, we need 1 to be a fraction that has a denominator of b. Now that's b over b. And in the denominator, we're going to subtract 1 from b over a, so I need a fraction that has a denominator of a that's equal to 1. Well, that's a over a, so we have b over a minus a over a. Now, that becomes b minus a over b over b minus a over a. Now remember, when you're dividing by a fraction, you flip the second fraction and multiply. So we have b minus a over b times a over b minus a. But once again, the b minus a's will cancel, and we're left with a over b. And that wasn't too bad. Now, that shows you the kind of thing that you're supposed to be doing in these problems. I will be doing some selected problems, and that'll be included, so I do encourage you to take a look at the solution videos as well. And we're done.